Hey everyone, it's your friendly neighborhood science enthusiast Beta here. So, picture this. You're chilling in your backyard, maybe grilling some burgers, and you see this small aircraft zipping through the sky. No pilot, no cockpit, just flying. That, my friends, is a drone. And if you're anything like me, your first thought is probably, whoa, cool, followed immediately by, wait, how does that even work? It's like magic, but it's actually some seriously awesome science and engineering packed into a tiny package. But these aren't just fancy remote-controlled toys anymore. Sure, you can get some epic vacation shots with them, but how do they stay so stable? How do they know where they're going, especially when they're miles away from the person controlling them? And more importantly, how did these things go from being a niche hobbyist gadget to something that's literally changing industries and even the way wars are fought? It's a pretty wild journey, and it's happening right now, all around us. So, buckle up, because in this video, we're going on a deep dive into the incredible world of drones. We're going to unpack the science behind their flight, explore all the mind-blowing ways they're being used, from farming to filmmaking to delivering packages, and even look at how they're becoming a game-changer on the battlefield. This is the story of how a cool piece of tech is reshaping our future, one propeller spin at a time. Let's get into it. All right, let's start with the basics. When we say drone, what are we actually talking about? The fancy official term is UAV, which stands for Unmanned Aerial Vehicle. Rolls right off the tongue, doesn't it? Basically, it's any aircraft that can fly without a human pilot physically sitting inside it. Instead, it's controlled remotely by someone on the ground. Or, and this is where it gets super interesting, it can fly autonomously using pre-programmed flight paths, or even artificial intelligence. Think of it like a super smart flying robot. Now, when you hear drone, you probably picture those small four-rotor gadgets you see buzzing around. And you're not wrong. Those are super common, especially for us regular folks. They're called quadcopters because, well, quad means four, and they have four rotors. But the world of drones is way bigger than just quadcopters. They come in all shapes and sizes, from tiny ones that can literally fit in the palm of your hand, to massive aircraft that look like something out of a sci-fi movie. The most common type you'll see, especially in the consumer market, is indeed the quadcopter. These guys are engineering marvels. They typically use electric motors to spin their propellers, which are powered by rechargeable lithium-ion batteries. To know where they are and where they're going, they're packed with GPS modules, just like your car's navigation system. And to keep them stable in the air, they use gyroscopes and accelerometers. These sensors are constantly measuring the drone's orientation and movement, feeding that data to an onboard computer. This little brain then makes thousands of tiny adjustments to the speed of each motor every second. It's like an incredibly fast, super precise balancing act. If the drone tilts a bit too much to the left, the computer tells the motors on the right to spin faster, pushing it back to level. It's this constant, rapid correction that gives drones their signature smooth and stable flight, even when there's a bit of wind. And of course, what's a drone without a camera? Most consumer drones come equipped with high-definition cameras, allowing them to capture stunning aerial photos and videos. This is what really opened up the floodgates for creative uses, from breathtaking landscape shots to dynamic action sequences in movies. But these cameras aren't just for pretty pictures. They also play a crucial role in navigation and obstacle avoidance for more advanced drones, acting as the eyes of the machine. So to recap, a drone is an unmanned flying machine. They vary massively in size and design, but the popular quadcopters rely on electric motors, lithium batteries for power, GPS for knowing their location, and a whole suite of sensors like gyroscopes and accelerometers to stay balanced and fly smoothly. It's a symphony of technology working together to achieve something that still feels a little bit like magic every time I see one take off. Okay, so we know what a drone is, but how does it actually get off the ground and zip around like a futuristic hummingbird? It all comes down to some pretty fundamental principles of physics, mainly aerodynamics and Newton's laws of motion, but applied in a really clever way, especially with quadcopters. It's not just about brute force, it's about finesse and incredibly fast calculations. For a typical quadcopter, you've got those four rotors. Each rotor is essentially a propeller attached to an electric motor. When these propellers spin, they push air downwards. Now, Newton's third law tells us that for every action, there's an equal and opposite reaction. So as the propellers push air down, the air pushes the propellers, and thus the drone, up. This upward force is called lift. If the lift generated by all 4 propellers is greater than the weight of the drone, up it goes. Simple, right? Well, mostly. The real magic happens in how the drone controls its movement, how it goes forward, backward, side to side, and how it turns. This is where the onboard internal processors, the brains of the operation, come into play. To make the drone fly forward, for example, the flight controller will tell the 2 rear motors to spin faster than the 2 front motors. This creates more lift at the back, causing the drone to tilt forward. With the drone tilted, some of the thrust from all 4 propellers is now directed backward, pushing the drone forward. It's a similar principle for moving sideways, roll, or backward. To roll to the right, the motors on the left spin faster, tilting the drone to the right, and part of the lift now pushes it sideways. To move backward, the front motors spin faster, tilting it back. And to turn, or yaw, the flight controller changes the speed of diagonal pairs of motors. 2 opposite propellers spin clockwise, and the other 2 spin counterclockwise. To yaw left, for instance, the clockwise spinning motors might speed up slightly, while the counterclockwise ones slow down, creating a net rotational force. Alright, so drones are engineering marvels. They fly in cool ways, but what are they actually doing out there in the real world? Besides maybe annoying your neighbor? Well, it turns out a lot. Drones are quietly, and sometimes not so quietly, revolutionizing a ton of industries, often in ways you wouldn't even expect. They're moving way beyond being just a hobbyist's toy or a photographer's new gadget. Let's start with agriculture. This might not be the first thing you think of, but drones are becoming indispensable tools for farmers. Imagine trying to walk through hundreds of acres of corn to check for pests, or see which areas need more water. It's a massive, time-consuming job. But a drone equipped with specialized cameras, like multispectral or thermal cameras, can fly over an entire field in a fraction of the time. It can identify stressed plants, detect irrigation issues, or even spot early signs of disease before they're visible to the naked eye. And it doesn't stop at just monitoring. Some agricultural drones are built like flying crop dusters, but way more precise. They can be used for targeted spraying of pesticides, herbicides, or fertilizers. Instead of dousing an entire field, which can be wasteful and environmentally damaging, these drones can apply chemicals only where they're needed, down to a very small area. This saves farmers money, reduces chemical runoff, and is ultimately better for the environment. It's precision agriculture at its finest. Then there's filmmaking and photography. This is probably one of the most visible uses of drones. Those sweeping, epic aerial shots in movies and TV shows that used to require expensive helicopters, cranes, or complicated cable cam setups. Now, a skilled drone pilot can capture them for a fraction of the cost, and with much more flexibility. From stunning nature documentaries to high-octane action sequences, drones have democratized aerial cinematography, allowing even independent filmmakers to get shots that were once out of reach. And it's not just Hollywood. Real estate agents use drones to get captivating aerial views of properties. Wedding photographers use them for unique group shots and romantic flyovers. News organizations use them to cover breaking events from perspectives that would be too dangerous or difficult for a human crew. The creative possibilities are pretty much endless, and we're constantly seeing new and innovative ways people are using drones to capture the world around us. How about getting your packages? Companies like Amazon with its Prime Air project and Google's parent company, Alphabet with its Wing subsidiary, have been seriously testing drone delivery services for years. Imagine ordering something online and having a drone drop it off in your backyard within 30 minutes. Now, we've seen how drones are transforming civilian life, but there's another, much more serious side to this technology, its use in military applications. And let me tell you, drones haven't just tweaked modern warfare, they've fundamentally changed the game. They've become an indispensable asset for armies around the world, offering capabilities that were once the stuff of science fiction. One of the earliest and still most critical military uses of drones is for ISR intelligence, surveillance, and reconnaissance. Imagine having persistent eyes in the sky over a battlefield or a sensitive area, 24/7, without putting a pilot's life at risk. Large surveillance drones like the American Global Hawk or Predator can fly at high altitudes for incredibly long durations, sometimes over 24 hours, collecting real-time video, intercepting communications, and gathering crucial intelligence. This constant stream of information gives commanders an unprecedented understanding of the situation on the ground. They can track enemy movements, identify targets, and make more informed decisions, all while keeping their personnel out of harm's way. It's like having a permanent, invisible scout that never gets tired and can see in the dark thanks to advanced sensors like infrared and radar. This capability alone has revolutionized how military operations are planned and executed. But drones aren't just for watching anymore. Many military drones, often called Unmanned Combat Aerial Vehicles or UCAVs, are armed. They can carry small, precision-guided missiles or bombs, allowing them to strike targets with incredible accuracy from a safe distance. This has led to the rise of targeted killings and precision strikes against enemy combatants or infrastructure, often in areas where sending in manned aircraft or ground troops would be too risky or politically sensitive. The use of armed drones has, of course, sparked a lot of debate and controversy regarding civilian casualties and the ethics of remote warfare, which we'll touch on later. But from a purely military perspective, the ability to project force with such precision and reduced risk to one's own soldiers is a massive tactical advantage. It allows for a more surgical approach to conflict, at least in theory, minimizing collateral damage compared to older, less accurate weapon systems. Okay, we've talked about all the amazing things drones can do, from delivering your pizza to winning wars. But as with any powerful technology, there's a flip side. It's not all sunshine and perfectly smooth aerial shots. There are some serious risks and legal challenges that come with a sky full of flying robots, and we need to talk about them if we're going to navigate this new era responsibly. First up, and this is a big one, privacy. Drones, especially those equipped with high-resolution cameras, can go almost anywhere and record almost anything. Imagine your neighbor flying a drone over your backyard, peering into your windows, or companies using drones to gather data on people without their consent. The potential for misuse, for surveillance, for a peeping Tom in the sky is a genuine concern for many people. Where do we draw the line between legitimate use and an unacceptable invasion of privacy? Then there are the security risks. Drones can be hacked. If someone can gain control of a drone, they could crash it, steal it, or worse, use it for malicious purposes. Think about a hacked delivery drone being rerouted to steal a valuable package, or a larger drone being commandeered and used to cause damage. There's also the risk of drones being used by criminals or terrorists to smuggle contraband, conduct surveillance on sensitive sites, or even carry out attacks. Securing drones against these threats is a major challenge. Interference with air traffic is another serious issue. We've all heard stories of drones flying too close to airports, forcing flights to be delayed or diverted. A collision between a drone and a manned aircraft, especially during takeoff or landing, could be catastrophic. That's why there are strict rules about flying drones near airports and above certain altitudes. But not everyone follows the rules, and even accidental incursions can pose a significant danger to aviation safety. This brings us to regulations. Because drones are a relatively new technology that exploded in popularity so quickly, governments around the world have been scrambling to catch up and create rules for their safe and responsible use. So there you have it. From a simple toy buzzing in the park to a sophisticated tactical tool on the battlefield, from a filmmaker's best friend to a farmer's most efficient helper, drones are undeniably reshaping our world in some pretty profound ways. We've seen how they fly, the incredible range of jobs they're taking on, and even some of the tricky questions they force us to ask about privacy, security, and the future of work and warfare. It's clear that these flying robots are much more than just a passing fad. Looking ahead, the sky's literally the limit. We can expect to see fleets of AI-guided drones becoming even more integrated into our daily lives. Imagine intelligent drones navigating complex cityscapes to deliver your groceries, swarms of them working together to monitor vast agricultural fields with pinpoint precision, or even highly autonomous drones performing dangerous search and rescue missions in disaster zones. On the flip side, we'll also likely see more sophisticated and autonomous drones on battlefields, which brings its own set of serious considerations. The question really becomes, are we ready for this age of intelligent flight? Are our laws, our infrastructure, and even our mindset prepared for a future where the skies are bustling with autonomous machines? It's a lot to think about, but one thing's for sure, it's going to be fascinating to watch it all unfold. Thanks for joining me on this deep dive, and as always, stay curious.